Good morning, students. So today we are going to discussing some standard results based on determinants. First one is for all x belongs to R, determinant of x plus 1, x plus 2, x plus 1, x plus 2, x plus 3, x plus 2, x plus 3, x plus 4 is equal to 0. Always this determinant like this. Any number, for suppose here 1. So next succeeding number, that means plus 1. That means if you take here 1, 2, 3, 2, 3, 4, 3, 4, 5, like that, if you have any number, that value becomes to 0. Not only one, if what is the number, if you start here, those succeeding numbers if you keep here, and what number you get, same number if you follow from this one, and what number you get for this one, same number if you follow for this row, then that determinant always becomes to 0. Okay, see, actually like these problems, no need to expand in determinant way. So you know how to expand. Here you keep plus minus plus if you want to expand in first row, and you take the sum of the product of the corresponding elements of any row or column to its corresponding cofactors, that gives the determinant. Okay, actually whenever you have in the determinant, variables are there like x, y, any variable. In that place, if you take any your favorite number, no problem. For suppose x is equal to 1, 0, 2, 3, 4, what number you, if you want, you take, no problem. So here I am taking x is equal to 1, so substitute here 1, 2, 3, 2, 3, 4, 3, 4, 5. Okay, this determinant if you expand, so once you check it out, so here plus, here minus, plus. Okay, plus 1 into, leave the row and column passing through 1, 3 5s are 15, 4 4s are 16, so 15 minus 16. Next minus 2 into, leave the row and column passing through 2, 2 5s are 10, 3 4s are 12, so 10 minus 12. Next plus 3 into, leave the row and column passing through 3, and cross multiplication, 2 4s are 8, 3 3s are 9, so plus 3 into 8 minus 9. Simplify, 15 minus 16 minus 1, 10 minus 12 minus 2, minus into minus plus, 2 into 2 4, here 8 minus 9 minus 1, 3 into minus 1 minus 3, so minus 1 plus 4 minus 3, that value becomes to 0. So like that. So not only one, you take any number, 1 2 3 whatever maybe you take, that value becomes to always 0 only. Okay, next same standard result, for all x belongs to R, determinant of x square, x plus 1 whole square, x plus 2 whole square, similarly. So what number here, from that number you start here, x plus 1 whole square, x plus 2 whole square, x plus 3 whole square, and the same number here, x plus 2 whole square, x plus 3 whole square, x plus 4 whole square. This value always becomes to minus 8. So for our convenience, if you want to verify this one, take x is equal to 0. For x is equal to 0, what you get? See, you can take 1 also, 2 also, no problem, but I am taking here 0, because if I take 1 or 2, you get big numbers. If you expand this one, you get big numbers. That's why I am taking x is equal to 0 here. So for x is equal to 0, this value becomes to 0, 1, 4, 4, sorry, this is 1, 4, 9, and this is 4, 9, 16. Take if x is equal to 0. Okay, so this is the determinant here. If you expand this one, same, plus minus plus. So actually 0 into anything gives 0 only, so no need to expand this for 0. Okay, so here plus minus, from this one you start here. Actually I am writing 0, 0 minus 1 into, leave the row and column passing through 1, so 1 16s are 16, 4 9s are 36, 16 minus 36, plus 4 into, leave the row and column passing through this 4, and you have 1 9s are 9, 4 4s are 16, 9 minus 16. So expand this one, 16 minus 36 minus 20, minus into minus plus, plus 20, and here 9 minus 16, 9 minus 16 means minus 7, so 4 7s are 28, so 20 minus 28, that gives minus 8. So if you take 1 2 3, what number you take, you get same value, minus 8 only. So next third result is determinant of 1 1 1 x y z x square y square z square is equal to x minus y into y minus z into z minus x. Actually, this is very very important for IPE also. If you go to IPE, that means intermediate public examination, if you want to go to write the intermediate public examination, don't verify, don't take x is equal to 1, y is equal to 2, z is equal to 3, like that. Don't take verification, because it is only useful for objective. If you want to do this one in intermediate public examination, we how to do this procedure. So I will explain. Actually, this one is equal to x minus y, y minus z, z minus x. This is also equal to 1 1 1 x y z, y z, z x, x y also. Same. This determinant also equal to this one. This determinant also equal to this one. See here. First, how to do in IP I will explain. After that, I go for objective. Okay. See here, what question they given. In that question, if you have ones are in any row or column, those at least those ones from these three ones, if you make at least two ones or zeros, our determinant will be easily expand. Because of same like here, here you got 0. For this 0, no need to expansion. Yes, so 0 into anything is 0 only. If you have this is also 0, same minus 0 into anything is 0, just you go for this 4 only. Like that, if you make these two zeros or these two zeros or these two zeros, then our problem will be very easy. Okay, see, sometimes they will ask the question, same question, prove this one without expanding the determinant. Without expanding the determinant means, okay, you have to do this procedure only. Directly we should not expand. That means we have to make at least two ones are zeros. Okay, how to make zeros? If for suppose these ones are in rows, then you have to use column operation. If for suppose these ones are in column, for suppose if ones are here, then you have to use row operation. See here, how to use column operation means, here because these are in row, so go for column operation. So C1 implies C1 minus C2. Already I told you determinant. Okay, how to write this one. C1 implies C1 minus C2. Because of here, C1 implies C1 minus C2. For this C1 I didn't multiply anything, but for C2 I multiplied minus 1. So this determinant is unaltered. See this one. According to properties of determinants, if all the elements of a row is multiplied with a non-zero number k, then the value of new determinant is k times of original determinant. Okay, so this is one property we have to use. And one more is, if any two rows or columns of matrix are identical, then that determinant is 0. Once again I am repeating, if any two rows or columns of given determinant are interchanged, then the sign of the value of new determinant is changed. And one more important is this one. If the elements of a row or column of a square matrix are added to k times of corresponding elements of any other row, then no change in the value of new determinant. C1 implies C1 plus 3C3. Example. Okay, if you multiply here, C1 is not, here C1 is going to change, but C3 is not going to change. I didn't multiply anything to C1. That is the important. Okay, same like, see here, based on this one. So if I make this one is 0, I should write a C1 implies C1 minus C2, because of 1 minus 1 0. And I should want to make a C2 making to 0. C2 implies C2 minus C3. Then this will becomes to 0. Actually, you just remember one thing. Whenever in a single step, if you want to change this one into new determinant, we should operate only two operations. Okay, because it is 3 by 3 matrix. For 3 by 3 we should apply only two operations. For 4 by 4 you should apply up to 3 operations. You can use, for suppose it is 3 by 3, we can use only one operation or both two operations. You have to use maximum two operations only, because of here C1 is going to change. C1 implies C1 minus C2. Here C2 implies C2 minus C3. Here, which columns are going to change? Two columns are going to change. So, which columns are going to change? We should not use those columns to any other operation. Because of, if you want to change C3 also, C3 implies we should write either C3 minus C1 or C3 minus C2. Because of already these two columns are changed, so we should not use these two columns for third column. So that's why you can apply only maximum two operations for 3 by 3 matrix. Same way, for suppose if you want to change the rows, okay, so we can, for suppose 3 by 3 determinant, we can use maximum two operations at a time. That is the important here. So which columns are going to change, those should not use. Actually, you ask me one question here, sir. Here C2 is going to change, but you used here C2. But after this one, I am using C2. Before C2 is not changed. For this operation, C2 not changed. After using C2, I use it. I change it to use this operation C2 implies C2 minus C3. Okay, so that is the important. So now go to LHS 1 XYZ x square y square z square. If you use first operation C1 implies C1 minus C2, that means C1 is going to change. So C1 minus C2 means 1 minus 1 0 x minus y x square minus y square, and C2 implies C2 minus C3, that means C2 is going to change 1 minus 1 y minus z y square minus z square, and C3 is not changed, so 1z z square. Directly you write. Okay, now here you can expand directly because these two are zeros, plus minus plus. So directly with 1 you can cross multiplication, directly you get the answer. But don't go directly, because of here there is a small simplification here 0. So always any simplification is there, any common factor is there, then you should take outside from that row or column. Okay, here 0 x minus y x square minus y square. So indirectly I observed here x square minus y square is nothing but x minus y into x plus y. So here x minus y is there, here also x minus y is there. 0 into x minus y is nothing but 0. For this 0, x minus y is not there, but you understand x minus y also one of the factor for 0. Okay, next here also 0 y minus z y square minus z square. That means y square minus z square is nothing but y minus z into y plus z. But in this column there is no common factor. So from this one you take from this one, from this is nothing but 0 into x minus y, this is x minus y, this is x minus y into x plus y. So from this first column if you take x minus y outside, from second column if you take y minus z outside, then from first column we have 0 1 x minus y, second column 0 1 y x plus y, this is 0 1 y plus z. After taking x minus y, here x plus y. After taking y minus z, here we have y plus z, and you write as it is 1 z z square. So next it doesn't have any common factor, so directly now expand it. So x minus y into y minus z into here g plus minus plus. You just remember here only, if you have at least 1 0 in the row, you go to expand through that row or column. If you have at least 2 zeros in that row or column, you should go to expand through that row or column only, because of our work will be easy. So here 0 zeros, no need to expand. Actually what is the sign for this one? Plus only you get it. Like that you understand, this is plus minus plus, so directly you go for 1. So plus 1 into, leave the row and column passing through 1, you have 1 into y plus z, minus of 1 into x plus y, minus of x plus y. That means x minus y into y minus z into 1 into y plus z minus of x plus y means x minus y. So this is equal to x minus y into y minus z into, here y get cancelled, z minus x is there. So x minus y into y minus z into z minus x. That is the answer we have to prove. Similarly, so same you take this one, 1 1 1 x y z y z z x z x y, same you get x minus y into y minus z into z minus x. Same procedure you apply here. So make it these two are zeros. Okay, so how to do in objective, that is the important. See Here these are the three different values, you understand. So take x is equal to 1, y is equal to 2, z is equal to 3. Actually in the objective you just remember one thing. What is the importance is here? Actually sometimes in the objective they give four options. Okay, if you take x is equal to 1, y is equal to 2, z is equal to 3, maybe this resulting value is equal to any two options or three options or all the four options. Then we have to change these values. Again we have to verify. Then you take x is equal to 0, y is equal to 1, z is equal to 2, like that we have to take. Generally if you take different values 1 2 3, maximum you get a single option only. If you take a 0, all ones, you can take all ones also, no problem. X is equal to 1, y is equal to 1, z is equal to 1 also you take. But in that cases you may get all options are same. Then you may get confusion which option is correct. Then you have to go for other different values. Generally if you go for 1 2 3, directly you get single option. Even if you are not getting, then you go for 2 3 4, like that. Okay, see here. So we can understand more by taking some examples in our objective questions. Okay, until just follow me. So here x is equal to 1, y is equal to, z is equal to 3, you take 1 1 1. Okay, 1 2 3, 1 4 9, directly expand it. So any row or column, actually I expanded through first row. So 1 into 2 9s are 18 minus 3 4s are 12, minus 1 into 1 9s are 9 minus 3, plus 1 into 1 4s are 4 minus 2. Okay, expand it. 18 minus 12, 6, 9 minus 3, 6 minus 6, 4 minus 2, 2, 6 minus 6 plus 2, that is equal to. Actually this is the, you can understand, this is only the option for that question. They may give some other options also. Substitute here, what you get? X is equal to 1, y is equal to 2, z is equal to 3. 1 minus 2 minus 1, 2 minus 3 minus 1, 3 minus 1, 2. So minus 1 into 2, that is equal to 2 only. So like that we have to verify. Next question. Similarly, these are the standard results. Like that just you take x is equal to 1 2 3, then you go for the option verification for the objective. IP means we have to expand like this. I will explain at the time of preparation, IP preparation again. Okay, but you can understand how to do these problems. So 1 1 1 x y z, x cube y cube z cube. What is the answer? X minus y minus z, z minus x into x plus y plus z. Fifth one, 1 1 1 x square y square z square, x cube y cube z cube. This is equal to x minus y into y minus z into z minus x into xy plus yz plus zx. Same, x y z, x square y square z square, x cube y cube z cube is equal to x minus y into y minus z into z minus x into xyz. Okay, you can understand. Here you actually, the degree of this determinant, actually you go to principal diagonal. 1 into 1 for 1 degree is 0, y degree is 1, z square degree is 2. So 1 plus 2, that is equal to 3. Observe the option. The degree of this polynomial is x minus y. That means this degree is 1, total degree is 1, this degree is 1, this degree is 1, 1 plus 1 plus 1 3. So those degrees also equal. Sometimes this is very useful to do the objective problems. For suppose third degree equation, third degree polynomials, if they given only one, then you go for directly that option only. Simply you go for that one without verification also. See here, so this degree is 0 1 3, total how much? 4. So this degree is 1 1 1 1, total 4. This degree 0 2 3, that means 5. So 1 1 1, this is xy plus yz plus zx. Xy degree is 2 2 2 2, total degree is 2. So 1 1 1 2, that is 5. So like that you can verify also. Okay, but if you have fifth degree equations for this question, if you have fifth degree equations are 2 are there in the options, then you have to go for verification. X is equal to 1 2 3, like that. Okay, now one I will explain in next video.